Hello students, Miss Slyman here with your notes on planes. And it's good that we're finally getting into equations of planes because we've seen them come up a few times and having the equations helps us. So hopefully you know a plane is a 2D surface, and to think of direction we need at least two different vectors to help us think of the direction of a plane. And then we also need to know a random point on the plane because remember, vectors can be anywhere. So if I have this vector, it could also be here, above the plane, below the plane, etc. So I need a point to actually fix onto the plane. So we need two vectors on the plane and a point that we know, which then lets us come up with this equation for any point on the plane. So this vector here can be thought of as a resultant of adding these two vectors. So if we know a point on the plane, then we can add multiples of these two vectors to get to any new point. And so that's where our vector equation of the plane comes from. So if we have the vector equation of the plane, we take any random point and then add multiples of those two vectors, because any multiples of those two vectors, remember these could be positive or negative, so any combination of those two will get us to any new point on the plane. So if we expand this, then we're going to get the parametric equations of the plane. So x will be the initial point plus some a1 and a scalar of b1. Y is going to be the initial point, our, z, z naught, s a3, t b3. So there's my parametric form. So my parametric form has two different scalars, the s and the t, and the given point, and we've got two different direction vectors, the a and the b.